It's 239 feet long, 7 stories tall at the tail, almost 262 feet from wingtip to wingtip. Heavier, longer, and taller than a 747, with 2 full levels of seating, enough to hold over 550 passengers. Getting this monster off the drawing board required new super lightweight materials, 4 powerful new mega-sized engines, massive new factories across Europe, and a computerized flight control system more sophisticated than any other in commercial aviation. This moment is the biggest gamble that the company has ever taken. A $12 billion investment. The company's entire future and the lives of future passengers all ride on the success of this historic test flight. Alongside the runway, a hush settles over the crowd as the mega plane comes into view. Gradually, it gathers speed, accelerating to reach its takeoff velocity of 167 miles per hour. Then, as it nears the end of the runway, the moment of truth, the massive nose tilts skyward. A sliver of daylight appears beneath the rear wheels, and the Airbus A-380 takes to the sky for the very first time. The engineers and technicians in the crowd breathe a collective sigh of relief. Their baby is flying. The question now is, does anyone want a plane this big? Will the unprecedented size prove a boon? Or a boondoggle? Is this super jumbo the future of commercial aviation? Or the biggest white elephant since Howard Hughes built the Spruce Goose? It all depends on whether Airbus can convince airlines that travelers will want to trust their fates to this flying cruise ship. No one yet knows the end of this story. But one thing is sure, any failure on this day, even a minor setback at this critical moment, would be a crushing and very public disaster for Airbus, with consequences that would reverberate around the world. The plane disappears from view. For the next 4 hours, while the flight crew puts this massive cruiser through its paces, the gathered crowd has little to do but wait, and perhaps reflect on the journey that brought them to this moment. The historic journey that began almost 40 years ago. 1969 was a year of technology firsts. That year saw the arrival of 2 exotic new airliners. Boeing rolled out the 747, the first double-decker passenger plane, larger and heavier than any other. Powered by 4 Pratt & Whitney JT9D engines, providing a total of 186,000 pounds of thrust. The plane had enough oomph to carry more than 400 passengers and their baggage, more than double the capacity of the 707. The plane wasn't an immediate hit, but eventually it took off.
The Concorde is here.
That same year, Aerospatiale and British Aircraft Corporation, the precursor to Airbus, introduced the Concorde. While Boeing was bulking up, the Europeans were getting smaller, but very fast. The Concorde traded capacity for speed. The plane carried only 128 passengers, but it could cruise at twice the speed of sound, cutting the trip from New York to London from almost 8 hours to just under 3.5. Both the 747 and the Concorde became the epitome of luxury in air travel. These 2 differing visions symbolize a fierce rivalry between American and European aerospace giants. A rivalry that's only intensified with time, even as the business of air travel has changed dramatically. The Concorde, after years of financial difficulties and a devastating crash in Paris, has been grounded. and the 747 is now an aging workhorse. Noted less for style and more for the sheer number of passengers it can pack between its wings. What changed to turn air travel from an exclusive transport to the airborne bus ride that it is today? Simple economics. In just a few short decades, the number of people traveling by air has tripled. Now, every day, hundreds of thousands of people pack into 70,000 flights, taking off and landing at more than 4,000 airports around the world. And those numbers are only getting bigger. Much bigger. Both Boeing and Airbus saw the writing on the wall in the 1990s, but the companies attacked the problem from different directions. Boeing believed that one of the biggest increases in air travel would be point-to-point flights. Get on near your home, get off near your destination. Boeing put its muscle behind the 787 Dreamliner, a highly efficient plane designed to carry an average of only 250 people. The A-380, though, is a totally different animal. It's designed for hub-to-hub travel. Passengers will board a small plane near their home, then connect at a major airport to a larger plane, travel halfway around the world, and get off at their final destination. It's a strategy specifically designed to serve the most rapidly expanding long-haul routes in and out of Asia, and to cater to customers who appreciate the lap of luxury. The plane's sheer size, with 2 passenger decks, is large enough for both standard seating, as well as more deluxe features, like a lounge, a high-end shop, 2 staircases, even a waterfall. It's a breathtaking dream. But no one knew if such a plane could be built. Some argued that such a craft would be far too heavy and expensive to be practical. But a tenacious and aptly named Airbus executive, Charles Champion, wouldn't take no for an answer. He encouraged his design team to think outside the box.
Yeah, well, there were lots of weird designs. Some looked at the double bubble.
One of their first ideas, the double bubble, a double-wide fuselage. It looked promising, but computer analysis showed that it would be far too heavy and not sufficiently aerodynamic. So Champion sent his team back to the drawing board, and eventually they came up with this history-making concept. A full-length double-decker passenger cabin with a 3rd deck below for cargo. Space-wise, it's the equivalent of 2 entire wide-body cabins, one on top of the other. The new plan called for an aircraft only 8 feet longer than Boeing's 747. It was 49 feet wider and 16 feet taller. But when they ran the design figures through the computer, they had a shock. The plane was far too heavy.
And we came up with horrid figures, saying, my God, this is the weight of the aircraft, doesn't work. So what we did immediately at the launch of the program, or 2-3 months afterwards, we launched a very strong challenge on the weight.
So the team set out to bring the base weight of the aircraft below 277 tons. That's only about 50% heavier than the 747. An ambitious goal for a plane designed to carry an additional 100 passengers and their luggage halfway around the world. Unless Champion and his engineers could find the means to beat that target, the dream would die. Engineers painstakingly construct A-380's high-tech mega wings with no room for error. Faced with a design challenge that called for a lightweight plane that could carry over 550 passengers at a lower cost per seat, not to mention quieter and less polluting than anything in the air, the design team knew they would have to rethink everything. They needed lighter materials, more powerful engines, larger wings, even bigger and smarter factories. Every component would have to be scaled up from supersize to mega size. But even while the engineers were still scratching their heads over the details, The Airbus sales force was already hard at work, seducing customers with visions of the future. They created a full-size interior mock-up that promised passengers in coach some relief from the grind of travel. With seats an inch wider than in other planes and overhead bins 10% larger. Each plane can also feature a new interior illumination system to eliminate the upsetting effect created when flight attendants suddenly switch on overhead lights. The kinder, gentler approach in the A-380 mimics the gradual transition from day to night and back to daytime again. These and other innovations make the plane distinctive, but it's the promise of opulent luxury that really turns heads. To help build excitement, computer programmers constructed a virtual showroom where airlines can bring to life their wildest design fantasies.
Ladies and gentlemen, this is your captain speaking. I'd like to welcome you on board this 3D tutorial for the A380 main deck door.
Using this 3D lab in cyberspace, airlines can experiment with cabin layouts, color schemes, and seating arrangements. Airbus has encouraged customers to think big. Bathrooms with showers, spacious lounge areas, restaurant bars, even an in-flight salon. But until the planes are actually put into service, most airlines have chosen to keep their final designs a closely guarded trade secret. But one early enthusiast, Richard Branson, Maverick founder of Virgin Atlantic Airlines, couldn't restrain himself. He announced plans for a deluxe version of the A380, featuring a casino and double beds on the upper deck. At a press conference, he famously quipped, "So alongside our casinos, you'll have at least 2 ways to get lucky on our flights." Of course, no dream could take flight until engineers came up with a way to lift all that weight. In late 2000, builders finally settled on a design. For power, they bought engines built by Rolls-Royce, capable of providing 30% more thrust than the engines used on the 747. Each massive power plant cost $15 million, as much as a ton of gold. Altogether, they account for almost 25% of the cost of the entire plane. But if there's one thing this aircraft needs, it's thrust that won't quit. Each engine provides up to 80,000 pounds of force. Running at top speed, this mega guzzler sucks down a gallon of gasoline in under 4 seconds. The A380 is designed for routine flights lasting 13 hours or more. That means when it's fully tanked for takeoff, the A380 carries a lot of fuel, over 68,000 gallons, 20% more than the load carried by the 747. The A380 engines are just one piece of the puzzle. Every other major component would have to be designed from the ground up. Fortunately, Airbus has already turned the world into a giant mega factory. With 1,500 suppliers and facilities used to build its existing planes scattered over 30 countries, yet tightly linked by an advanced communication and transportation network. To assemble the hundreds of A380s the company hopes to sell in the coming decades, planners settled on 5 countries to build the major components. Wings in Wales, engines in England, the fuselage and vertical tail section in Germany, the horizontal tail section in Spain, and of course, France, where all the pieces come together to assemble the finished plane. The process begins in Wales, in 2 huge new wing factories built to assemble the largest and most structurally complex commercial airplane wings ever designed. 32,000 components shipped in from every continent except Antarctica. The wings on the A380 are true mechanical marvels. They provide flight control and enough lift to carry the fuselage, plus the 4 supercharged engines, each weighing nearly 6.5 tons. And with over 68,000 gallons of fuel loaded inside 10 interior locations, the wings are also flying fuel tanks. They're one of the most critical structural components in the entire aircraft. The precision construction process begins with sheets of aluminum, destined to be shaped into the 10 panels that cover each wing. Each piece has its own shape and weight requirements. To whip one up, just follow 3 not-so-easy steps. Shave it, wrap it, then bake it. This 111-foot slab of aluminum weighs in at 5 tons. Way too heavy for the wing panel it's destined to become. In its final form, it will weigh close to 1 ton. So off it goes to get the aerospace equivalent of a tummy tuck. Now it's under the control of a massive horizontal metal shaping device, a 131-foot-long milling machine. Like an oversized cheese grater, the precision cutting head slowly cuts back and forth across the surface of the wing, painstakingly shaving the aluminum until the panel's shape matches the 3D contour map stored in the machine's computer. The process takes up to 3 days and eliminates 75% of the panel's weight while maintaining its strength. Then it's ready for the oven, one of the world's largest pressurized heat chambers, 138 feet long, almost 20 feet wide. Technician John Massey has cooked plenty of wings for smaller Airbus planes like the A-380.
It's a challenge to see it go from the size of the 320 to the size of the 380. It's a huge, huge jump.
The A380 wings are 50% larger than A320 wings. That means a 50% greater chance of error in this critical process. Baking requires careful setup. First, Massey and others place the segment in a special metallic form. Then they vacuum seal the entire assembly with a massive piece of plastic shrink wrap to protect the metal from contamination. Inside, the heat must be uniform across the entire panel, 302 degrees Fahrenheit, with no room for error.
We try to avoid any changes in the vacuum or the temperature, so the temperature must remain constant right throughout the process. It must maintain within 3 degrees, otherwise the run has been validated.
After 24 hours, the panel is finally ready. Specially equipped vehicles rise up and move into place in front of the oven. All eyes are on the plastic protecting the wing panel. If it breaks, the aluminum wing piece is compromised. A disaster. The entire wing panel would be worthless.
If the bag bursts, it means starting the job again from scratch.
Anxiously, they scan the surface for any breach. At last, the wing is cool enough to touch. And good news, the bag appears to be intact. Finally, the wing segment arrives in its docking bay. Here, the technicians first remove the plastic and cloth wrap. Now begins the tedious search for flaws. John's boss, Gareth Williams, arrives to inspect the piece. He retrieves small metal rods that were baked onto the top of the wing panel. Each of these cylinders tells an important story about future safety.
These are test pieces which are made of the same material as the wing panel, and we use them to confirm that the heat process that this part's just gone through is correct and it's to the right specification.
When this testing phase is complete, Gareth and John get the okay to move the wing to its next destination. The nearby wing assembly plant, an enormous brand new factory located just up the road. It's one of Britain's largest industrial buildings built in this century. At nearly 279,000 square feet, it's the size of 15 football fields. This is where the builders attach the aluminum skin panels to the wing skeleton. George Lee guides his team through the tricky assembly process. Today they're preparing to lift and place one of the largest of the 20 aluminum panels, 111 feet long and weighing in at more than 1 ton. The panel hangs like a huge guillotine, suspended over the factory floor. But that's not all that's hanging over the assembly team's head. Time is running out. Along the edges of the partially constructed wing, builders have applied a sealant that will help to ensure the integrity of the fuel tanks. The sealant dries quickly, within hours, The team must fit the wing panel into place before the sealant dries, or the wing could be defective. This time, they're cutting it close.
The only concern I've got is the time factor.
If they don't succeed, the team will have to scour the sealant off the aluminum surface and start the whole process all over again. Finally, the panel settles into place. 1 down, 9 to go. But it takes more than a wing to make a plane. All across Europe, more factories are coming online, pumping out body parts of this giant Frankenplane. But not everyone is happy to see this kind of progress. Some locals in Germany are up in arms over Airbus's ambitious plans. Passenger lives depend on the integrity of this diamond-tough tail fin. This is the newest Airbus factory in Hamburg. A mega structure big enough to house 4 A-380s side by side. Airbus has been building airplane fuselages in Germany for more than 30 years. But with the announcement of the A-380, the company needed to massively expand the site and send the finished planes here to get tricked out on the inside and painted on the outside. No matter what the customer wants their plane to be, a 550-seat cattle car, a high-class hotel in the sky, or even a heavy-duty freighter, this is where the seats, the carpets, the stairs, and yes, even the bar and the waterfall will all be installed. The expansion plan called for 3 new buildings and a longer runway to accommodate the massive plane. But there was a problem. Airbus's main factory here sits alongside Germany's Elbe River, smack dab in the middle of Europe's largest tidal wetlands.
It's a very special area because we have there the influence of water from the country and the tidal water from the sea. So we have a mixture of sweet water and salt water.
This fragile ecosystem is home to 70 species of migratory birds. 71 if you count the Airbus A380. Airbus wanted to fill in 346 acres of pristine wetland, and local activists cried foul. A heated battle in the courts and demonstrations in the streets delayed construction of the factories for over 2 years. But eventually, local and national politicians who wanted to bring business to the community intervened. The factories went up. 1 got busy building fuselage segments, but the other 2 stand nearly empty. More lawsuits still block the Hamburg facility from taking delivery of all of the planes it's meant to finish. Unless the company wins in court, it may have spent a few $100 million building an elaborate but useless factory. The problem lies with the runway. Airbus needs a longer runway to accommodate a heavy-duty cargo version of the A380.
We need the runway extension in Hamburg for the pilot to test the performance of the aircraft. And he only can test this when he has an aircraft with a weight which is approximately the weight you normally have in cruise altitude and a normal scheduled flight.
That plan to lengthen Hamburg's existing runway has met with considerable resistance from locals. Their concern? Extending the runway will bring the tarmac to within less than 1/3 of a mile of village orchards, and uncomfortably close to a Lutheran church that houses a priceless organ built in 1688. A delicate instrument that could be damaged by ground vibrations and wake vortices, turbulent bands of air similar to miniature tornadoes.
We have very precise information on is the generation of these wake vortices, so small, let's say, tornadoes, wind generated by every aircraft, more or less, which can affect buildings and also persons close to the runway or close to the flight path. And we have predictions that we should expect occasionally winds up to Beaufort 12, which is about 130 kilometers per hour in the core, and these tornadoes will hit the church tower and the roof construction.
Villagers may have reason to be concerned. For years, they've tolerated another big plane in Airbus's fleet, the Beluga, a custom-built freighter named for the white whale it resembles. The Beluga, smaller than the A-380, was custom-built in 1996 to carry pieces of Airbus planes to and from various factories. Village people and builders have already felt the shaking caused by the Beluga, which may get worse when the much larger A-380 comes to town. Airbus contends that fears are overblown, but if the protesters win, Airbus may have no choice but to pull up stakes and build the freighter factory and runway somewhere else. Which group will come out on top? The local villagers or the corporate giant? The lawsuits are still working their way through the courts. Legal action by angry locals is one risk the company is vulnerable to. But just 35 miles away, in the town of Stade, another big gamble is underway. The company is using a futuristic material to build the largest commercial aviation tail fin in the world. It's called carbon fiber reinforced plastic, and it's made out of the same stuff that gives diamonds their incredible strength. Carbon fiber is 6 times stiffer than steel, and much lighter. It's the only option if builders are going to keep the weight of the plane below the targeted 277 tons. Unlike forged metal, carbon-reinforced plastic parts are actually woven, like fabric. Fabricating machines spin out tail panels by combining super-strong carbon fibers with plastic resin to create almost any shape the designers can imagine. After baking, strengthening, painting, and drying, technicians join the lightweight panels to the tail skeleton. With the help of this computer-controlled riveting robot. Working around the clock for a week, the robot makes 10,000 critical connections, within tolerances no human can match. The integrity of the tail fin is crucial to the safety of passengers. Airbus engineers know only too well what can happen if a tail structure fails. In 2001, American Airlines Flight 587 left JFK Airport in New York. Less than 3 minutes later, the Airbus A-300 aircraft had crashed in Rockaway, a neighborhood in Queens, New York.
The piece went left side and they can spread all over down.
It was the second deadliest crash in U.S. history, and investigators made a disturbing discovery. It had been caused when the tail fin and rudder, made partly out of composite materials, sheared off as the plane accelerated. Investigators concluded that cockpit errors, not a failure of the carbon composite material, most likely caused the crash. And builders have applied the lessons of that catastrophe to the tail fin of the A-380. But today, something's gone wrong on the factory floor. A lightning strike zapped the power supply, and now the precision riveting robot is dead in the water.
We had a storm, a lightning strike. The PC failed, and the hard disk was completely gone.
Mother Nature has thrown a wrench into the works, causing a total crash of the system.
It's electricity. Sometimes it happens. Normally we are protected, but it can just happen.
Critical hours pass as Kai Baumgartner and his colleagues struggle to get the robot back online. If they can't fix the computer, they can't make the deadline set for finishing this tail fin. Kai and his team must find the problem, and quickly. By the end of the shift, the sound of riveting echoes through the factory once again. Kai is finally back at work, personally verifying that every one of the 10,000 connections is perfect. A tiny camera positioned on the end of the riveting machine allows Kai to carefully examine each rivet, making sure to catch any abnormalities in the process.
I make sure that the drill doesn't get stuck or any mistakes happen. I have my different systems here. It can happen that something is stuck or that an error occurs.
It's a repetitive process. But Kai must remain vigilant to safeguard the lives of future passengers. Around the world, manufacturers and suppliers are putting the finishing touches on the components of the A380. But putting all the pieces together will be a logistical nightmare. Airbus's existing transport system, the custom-built mega freighter called the Beluga, is too small to haul A380 components to the assembly factory in Toulouse, France. So builders came up with a risky plan to haul millions of dollars of critical components by water and land. Airbus had a problem. They needed to move pieces for the largest passenger plane in the world from factories all over Europe to their final assembly plant in Toulouse, France. For smaller planes, they could use the Beluga, Airbus's distinctive custom-built transport plane. The Beluga's cargo hold measures 23 feet high, 23 feet wide, and 125 feet long, big enough to swallow the fuselage, wings, and tail sections of Airbus passenger planes like the 150-seat A320. But when Airbus decided to build the massive A380, the sheer size of the parts overwhelmed even the Beluga. The Beluga is far too small to carry the A380's enormous triple-decker fuselage or its record-breaking wings. So to get their parts to the assembly plants, the company now had to move them by sea and over land. Instead of a 2-hour ride in the belly of the Beluga, parts for the A380 joined a days-long parade of specially outfitted ships, river barges, and trucks. Keeping this massive system on schedule is the job of Service Transport Coordinator Philippe Nedelec, who has to keep it all moving fast.
I like to say that I am a kind of conductor. I have to impose the tempo to everybody.
Wings and fuselage arrive by sea in the port city of Pauillac in Bordeaux. From there, it's 60 miles by barge down the Garonne River. With a bit of tricky navigation to clear the historic Pont de Pierre Bridge, a prized landmark built by Napoleon almost 200 years ago.
We have to cross a very old bridge. And at the beginning, the Bordeaux people were very afraid. What these Airbus people are going to do with our nice bridge.
To maneuver beneath the Pont de Pierre, Philippe and his team keep careful track of the tides and the weather. If they don't time their trip just right, if the water is too high or the currents too strong, they could collide with the bridge, destroying precious cargo and damaging a priceless piece of history as well. But waiting for the perfect moment isn't always an option.
Suppose we miss a call for weather condition or some other things, then the boat can miss a tide, so we can miss 6 hours, and this 6 hours you can miss 1 week, because we cannot start the convoy, the road convoy, every day. It's not so easy. We cannot start when you want.
Every pass under the bridge is a potential disaster. This time, they make it through, but just barely. Next, it's a handoff to a fleet of trucks and their escorts. Now it's a slow crawl, 10 miles per hour for the last 155 miles of the journey.
You cannot leave these trucks alone, so you have some trucks for assistance. One convoy is 6 trucks, plus, I would say, 15 vans, plus some cars, plus motorbikes. Almost 60 people moving from 10 at night to 5 to 6 in the morning after.
It's a bizarre display. Giant airplane parts inching along narrow French village roads, sometimes coming within just 20 inches of buildings. No matter what time of night, crowds gather to watch this late-night parade of parts.
You see these people at 2 o'clock in the morning and you don't know which attitude you must have. Sometimes you say hello, hello. It's very, very strange. People are very, very interested with that and very pleased. It's like a show, a permanent show, paid by Airbus.
So far, this roadshow has had an exotic appeal. But will they still be clapping when convoys like this grind through town once a week? Ultimately, that's the pace Airbus will have to keep if they're to meet their manufacturing targets. At last, the convoy arrives at its destination, the final assembly line, the nerve center of the entire operation. The final assembly line sits on the edge of Toulouse's Blagnac Airport. As with all A380 factories, this one is huge. 1,640 feet long by 820 feet wide and 15 stories tall. 32,000 tons of steel, enough to build 3 Eiffel Towers. It's in here that the massive plane finally begins to take shape, with the help of a gargantuan assembly structure known as a jig. According to Julien Pouillou, there's nothing else like it in the world.
We're standing in front of the biggest jig that is used in the world to assemble an aircraft. This is the Station 40.
Station 40 is where the fuselage, wings, and tail all come together. This one-of-a-kind jig stands 5 stories tall, weighs 1,200 tons, and comes equipped with 4 elevators to carry workers to their stations. This is where theory becomes reality. As pieces made all over the world finally come together, if there's been any error, if the pieces don't measure up to spec, or if the joints don't come together just right, within millimeters, the huge passenger craft won't be fit for flying. The lives of future passengers depend on the steady hands of these craftspeople and engineers working inside the mighty Station 40.
The challenge is for us to assemble those pieces together at the same time, because we have a lot of workers working in the same area at the same time, and they have to do all sorts of completely different tasks. One has to take care of the wings, and one has to take care of the fuselage, and so they are not doing the same job, but they have to do it together.
Work on this plane now proceeds at an intense pace. It'll take 4 weeks to complete the assembly. Once the plane has been released from Station 40, it moves through a pair of 328 feet wide sliding doors and makes its way to the systems hall. Inside this gigantic space, 3 A380s can sit side by side comfortably, while technicians swarm over the superstructure, testing the electrical, hydraulic, and plumbing systems that will bring the dormant aircraft to life. Building just one A380 is a massive job, but for Airbus to survive, they're going to have to speed up production to a breakneck pace. Eventually, the Station 40 team will have to crank out a perfect, defect-free plane every week. But before that can happen, the plane must be proven airworthy. Now, all eyes are on the skies over southern France as the gathered crowd wonders, will the A380 survive its maiden flight? At Blagnac Airport in Toulouse, 40,000 people anxiously scan the skies, searching for some sign of the A380. All flights in and out of the airport are suspended. The skies over Toulouse are eerily quiet. Nearly 4 hours have passed since takeoff. If all goes as planned, the huge airliner should swing into view at any moment. But if there's a problem, the flight crew will quickly discover how well their training has prepared them for disaster. Much of that training took place using powerful computers, programmed to mimic the behavior of the A380. That's the theory anyway. In a simulator like this one, with a computational engine 500 times more powerful than a home video game console, photorealistic visuals help pilots to get a feel for the plane. Despite the A380's unprecedented size, Airbus engineers have tried to make it fly like any other airliner.
100 knots.
The task of testing the verisimilitude of the simulator rests on pilot Claude Holbeck.
I would say that it's exactly as a commercial aircraft. And it's quite amazing because this aircraft is so big and so heavy. this surprised most of people, and especially pilots.
One of the most important functions of simulators is to give pilots the chance to flirt with disaster.
Very simple, and one engine is shut off. This is the engine number 4, and look what is happening. The aircraft is just moving slowly on the right side.
It takes a lot more than an engine failure to knock this monster out of the sky. But test engineers are nothing if not imaginative. And they've loaded their simulators with more than 400 different catastrophic scenarios. Everything from a fire in the cargo hold to a devastating lightning strike. The exercises are useful, but no computer can simulate the awesome responsibility of shepherding 550 passengers through the stratosphere.
The challenge is to fly with many passengers. I think this is the greatest challenge, yes.
Outside, all eyes are on the sky. The weight is excruciating. Then, a glint of reflected light. At last, the megaplane sails into view. Eager reporters and photographers race to the edge of the tarmac to record this historic moment. A showy flyby excites the crowd. The plane makes a steep turn, lines up with the runway, begins its final descent. Then, at long last, touchdown. Like astronauts returning from space, the pilots and the flight engineers greet the crowd. It's one for the record books. If nothing else, the A-380 is a public relations success. Journalists from around the world scramble to file their stories. Chief architect of the entire project, Charles Champion, is proud and relieved.
I think it was a great moment of emotion, and somehow we did it. You know, it's alive. It's alive.
They've proven that the plane can fly, but that may have been the easy part. At the time of the test flight, Airbus had 154 orders and still needed 96 more to break even. To fill those orders, they must dramatically increase the speed of production and convince the world's airlines to pay nearly $300 million for each plane. But even while potential customers were lining up to drool over the lavish decor, and the engineering team was still basking in the afterglow of the successful first flight, Airbus surprised the industry by unexpectedly announcing a 6-month delay in the delivery of the first aircraft. Early customers who took the risk and put down deposits before the first plane had ever been built are not happy. Some analysts believe the plane is still heavier than Airbus promised. But Airbus insists that the delay is merely routine.
The real achievement will be when the customer says, great, this is what I expected, I love it, give me more.
If the last 40 years in the history of aviation are any indication, and more people continue to fly further and more often, year after year, then Airbus's daring bet may well pay off. And the A380 just might become the flagship of commercial aviation well into the 21st century.